The major superpowers of the world are now in race to develop a fifth generation fighter jet program, or they have already developed it. Only a few handful of countries have operationalized their fifth generation fighter jet, which includes US, Russia, and China. Turkey and South Korea are also in race to develop their fifth generation fighter jet. Turkey's Khan took its first flight on 21st February 2024, and South Korea has built and flight tested its multiple prototypes of KF-21 fighter jet. However, the country which is an immediate threat for India is its troubling neighbors China and Pakistan. The recent satellite images from May 2024 has shown that China has deployed its latest fifth generation fighter jet at its airbase close to Indian borders. At least 7 J-20 fighter jets has been spotted at Shigaste airbase, which is in Tibet. This airbase is located at an altitude of 12,408 feet. The deployment of J-20 shows the China's ability to operate the aircraft from such a high altitude Tibetan airbase. Shigatse airfield is just 150 kilometers away from Sikkim border and also lies less than 300 kilometers from Indian Air Force base in Hasimara, which is home to Indian Air Force 2nd Squadron of 16 Rafale fighter jets. It has also been reported that till date China has built nearly 250 J-20 fighter aircrafts. The deployment of J-20 at the forward airbase of China facing India poses a major threat for Indian Air Force. China has been steadily building up its air power capability in Tibet and other areas near India over the past 5 years, which includes the construction of new air bases and upgrading the infrastructure at existing air bases. Now, to counter the Chinese latest fighter jets, Indian Air Force has just 32 Rafale as the most latest and modern 4.5th generation fighter jet. However, China enjoys the numerical superiority and has capability to domestically produce J-20 fighter jets. Therefore, India is in desperate need of its domestically developed fifth generation fighter jet, which could be produced in large numbers and economically viable. Now, this brings us to India's Advanced Medium Combat Aircraft or AMCA program. This program has been running for years with little to no fund for its development. It finally gained the momentum with approval of fund for prototype development by Cabinet Committee on Security on 7th March 2024. ADA has planned to develop 5 prototypes of AMCA for flight testing at an estimated cost of Rs 15,000 crore. The cost of fighter jet will further reduce when the aircraft enters into full-fledged production. Now, since AMC is an indigenous fighter, it would be still 50 to 60% cheaper than the imported fighters in its category. Now, let's look into what has been progressed in AMCA development. In May 2024, CB Anant Krishnan, the HAL's chairman and managing director, has told Business Standard that AMC project has just begun and it is coming along well. About 35 to 40% of aircraft has been allocated to HAL to design. The rest of aircraft is being designed by ADA. There is no third design partner. So HAL is now going to be doing the complete structural design of AMCA except for the central fuselage, which ADA will design. While the Ministry of Defense is keen on bringing in the private industry immediately at design and development stage, however, the private firms would like to participate in production programs only after completing design and development to avoid the locking in funds during an inevitably long gestation period. The AMCA program, as we all know, has completed its critical design review, that is CDR, in December 2023. The business standard has also reported that AMCA's stealth shaping is now complete, its design is now mature, and its internal systems are fully laid out. The way is clear for now metal cutting, which is a symbolic start of construction of a flying prototype. HAL will now have to develop some systems and build 5 prototypes, which is a 4-year long job. India Today in early 2024 has also reported that ADA has 10-year roadmap for making 5 prototypes and flight testing thereafter. The first prototype itself would take 4 years to manufacture. If all goes according to plan, the AMCA will start being manufactured from 2035 onwards. The former Chief of Air Staff, R.K. Bhaduria, has also said that based on his discussion with the ADA chief, the plan is for the first flight in 4.5 years and initial operational clearance in 10 years. So, to summarize, AMCA will take 10 years to enter into production. However, technology featured in the aircraft will not be obsolete, as DRDO is iteratively developing and enhancing various electronics, avionics, radars, and sensor technologies. These new sensors, weapons, and avionics can be seen in the upcoming fighter jet, such as LCTS Mark 1A and Mark 2. Indian Air Force will be inducting AMCA from 2035 onwards. 7 squadrons of AMCA have been planned to be inducted, which includes 2 squadrons of AMCA Mark 1 powered by GF414 engines, which will be made in India, and 5 squadrons of AMCA Mark II, which will be powered by an indigenous engine, which is planned to be developed with foreign collaboration. Now that we have discussed in detail about AMCA development progress, let's discuss in detail about the capabilities of India's upcoming 5th generation fighter jet. Talking about the common features and specifications of AMCA, it will have an overall length of 17.6 meter, wingspan of 11.13 meter. It will have maximum takeoff weight of 25,000 kg and max weapons payload capacity of 6,500 kg. AMCA will have 14 hard points where it can carry the 6,500 kg of weapons payload. In stealth mode, AMCA will carry only in its internal weapons bay, having total payload capacity of 1,500 kg, where it can carry 4 missiles. So in its internal weapons bay, it will be able to carry 2 Astra beyond visual range air-to missile and 2 Tara missiles. AMCA can also carry 2 SAW bombs in place of 1 Tara missile. In a different configuration, AMCA can carry 4 Astra or 8 SAW or 4 precision guided munitions such as JDAM or Tara in its internal weapons bay. In non-stealth mode, the aircraft will carry 6,500 kg of weapons, including internal weapons bay and external pylons. AMCA's fuel carrying capacity is 6,500 kg, which is almost more than 2.5 times of LCA, which has fuel capacity of 2,400 kg. The max speed of fighter jet is going to be 2,600 km per hour or Mach 2.15 with combat range of 1,620 km and service ceiling of 20 km. AMCA will incorporate features like serpentine air intake to reduce its infrared signature, internal weapons bay, aligned edges, and heavy use of radar absorbent materials to provide it the desired stealth characteristics. The divertless supersonic inlet or DSI with serpentine decks will conceal the engine fan blades to reduce its IF signature. AMCA is being designed to have first look, first kill capability. To achieve this, AMCA will feature long-range radars and sensors with extended range. The 3 most important sensors of AMCA is going to be gallium nitride based Uttam AESA radar, IRST sensor, and integrated electronic warfare suite. The IRST is a passive sensor and will be capable of detecting targets in the range excess of 100 kilometers. DRDO is also working on indigenous laser designation pod or LDP, which is used for detection, recognition, identification, and designation of surface targets. The distributed passive sensors with artificial intelligence assisted multi-sensor data fusion will increase the situational awareness of the pilot. the system will work in tandem with Advanced Electronic Warfare Suite. The distributed processing system of AMCA will feature fast processors and smart subsystems. The early warning system and network-centric warfare capability of AMCA is further going to increase the coordination among the pilots. The advanced situational awareness in AMCA is achieved through multispectral sensors placed across the airframe of fighter, which will allow fighter to have 360-degree of visibility without maneuvering the fighter. This is an important characteristic of AMCA which will enable the first look, first kill capability. AMCA pilot will be able to detect and destroy adversary's fighter aircraft without revealing its presence to the opponents. Another interesting feature of AMCA is going to be voice-activated cockpit. AMCA will have 3D audio warning system in cockpit and voice-activated commands which will reduce the workload of pilots. The AMCA will have a glass cockpit equipped with a panoramic touchscreen display for enhanced man-machine interaction, a multifunctional display placed in portrait orientation, and a wide-angle holographic heads-up display. The AMCA will have hands-on throttle and stick HOTAS arrangement with right hand on stick and left hand on throttle setting to ease the pilot workload.
This was today's update. Please let us know your views on this in comment section. If you like the video, do not forget to like, share and subscribe. With this, I would like to say goodbye and Jai Hind. We'll soon back with more interesting and amazing development happening in the defense sector.